Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome back to Audit with Ahmad. This is the start of our brand new lecture series on CAF 3 Data Systems and Risk. Now, this subject is extremely important, not just for exams, but also for your professional career as a future accountant, auditor, or finance professional. Because let's be honest, today everything revolves around data. Organizations survive and grow only if they can manage their data properly and safeguard it from risk. So, in this first lecture, we are going to begin with chapter 1, that is types of data and sources. By the end of this lecture, you will understand the different categories of data, learn how organizations classify data, know where data actually comes from, and appreciate why the right data is the foundation for all decision making. Let's start with very basics. What is data? Data is simply raw facts and figures. It's not yet meaningful until we process it. For example, a list of numbers like 100, 200, 300, and so on, that's just data. But if I tell you these are sales figure for 3 days or more, now it becomes information. So remember, data is raw. Information is processed and meaningful data. And in the bigger picture, when information is applied with judgment and experience, it becomes knowledge. Now, let's get into the classification. Data is usually categorized into different types. This is very important for exams, so note it carefully. Structured data is the type that is organized, stored in rows and columns, and easy to search. For example, sales records in Excel sheet, bank transactions in a database, customer names and addresses. This is the kind of data that computers can handle very easily because it has a defined format. On the other hand, we have unstructured data. This is data that does not have a predefined structure. It's messy, it's varied, and it's harder to analyze. For example, emails, social media posts, videos, images, audio files, customer feedback in free text form. In fact, research suggests that more than 80% of all data in organizations is unstructured. That's huge. And this is where tools like artificial intelligence and natural language processing come in to make sense of this data. In between structured and unstructured, we have semi-structured data. This type of data does not fit neatly into rows and columns, but it still has some organizing elements like tags or markers. For example, extensible markup language or XML files, JavaScript object notation or JSON data, and also log files from web servers. So, semi structured data is somewhat organized but not rigid like structured data. Now comes the buzzword big data. Big data refers to extremely large and complex datasets that traditional systems cannot handle. It is often defined by the famous 4 V's, and these 4 V's are volume, velocity, verity, and veracity. Where volume is huge amounts of data and velocity is data coming in at high speed. Verity is data in multiple formats, while veracity is uncertainty about accuracy or quality. For example, think about the data generated by Facebook every second, like posts, likes, comments, videos, photos, friend requests. That's big data. Another important classification is master data and transactional data, where master data is the core data that does not change frequently. For example, product codes, employee records, supplier details, while transactional data is the records, like day-to-day business records or events. For example, sales orders, purchase invoices, payroll entries. Master data is like the foundation, while transactional data is the activity happening on top of it, which is like day-to-day activity. Okay, let's pause for a recap. We said data is raw facts, information is processed data. Data can be structured, unstructured, semi structured, or big data. Data can also be master data or transactional data. Now, my question to you, can you think of an example from your daily life where you deal with structured data and another where you deal with unstructured data? For instance, your bank statement is structured while your WhatsApp chats are unstructured. Alright, now let's move to another very important part. Where does this data actually come from? Or in other words, what are the sources of data available to an organization? Data can broadly come from inside the organization or from outside the organization as well. And internal data sources is data generated within the business itself. For example, sales invoices, payroll records, production logs, internal emails or communications, and customer complaints recorded in the system. While, on the other hand, external data sources comes from outside the business, often from market or environment, like market research reports, government publications, social media platforms, and customer reviews on the internet. Think of it like this: internal data is your homegrown information, while external data is like intel from the outside world that helps you understand your environment. Another common way of classifying sources is primary and secondary data. Primary data is collected firsthand for a specific purpose. Like you want to know customer satisfaction, so you design a survey and collect responses directly. That's your primary data. While secondary data is data that already exists and collected by someone else, but you use it for your own analysis, like using a published industry report or government census data for your business needs. So, primary is like cooking from scratch, while secondary is like reheating food that's already prepared. In the old days, data was mostly collected manually through paper forms, registers, and physical documents. But today, most data is collected digitally through software systems, sensors, mobile apps, and the internet. Still, in many businesses, especially in developing countries, you will find a mix of both. For example, a hospital might record patient data manually on paper and then later transfer it into a digital system. Now, earlier when we talked about semi-structured data, I mentioned some terms that may be new for many of you, like XML files, JSON data, and log files. Let's explain them in simple words. Extensible markup language or XML is a way of storing and transporting data in a tag-based format. Think of it like a set of digital labels that describe data. And here is the example. This tells us that the student's name is Ali and roll number is 101. So XML is human readable, and at the same time computers can process it easily. It's widely used in databases, financial data exchange, and web applications. JavaScript Object Notation or JSON is another popular way of storing data, especially used in web apps and mobile apps. It looks like this. JSON is simpler than XML, uses fewer characters, and is very popular in modern technology. For example, when apps on your phone send and receive data from a server, log files from web servers are like a diary maintained by a computer system. Whenever you visit a website, the server automatically records details like your IP address, the time you visited, the pages you opened, and also errors that occurred. All of this goes into a log file, which is your record, which is equally like record keeping. For businesses, these log files are very valuable because they show user behavior. For example, an e-commerce company can analyze log files to see which products customers are searching for most often or where they are dropping off during checkout. Okay, let's quickly recap this part. Data sources can be internal, like sales records, or external, like market reports. They can be primary, collected firsthand, or secondary, like already existing. In today's world, most data is collected digitally, but manual sources still exist. And some special formats like XML, JSON, and log files are used in IT systems to store, transfer, and analyze data. So far, we have learned about the types of data and where data comes from. But here's the reality. Not all data is automatically valuable. For example, if you collect customer feedback but half of it is incomplete or outdated, then it's not very helpful. This brings us to our next important concept, the characteristics of good data. Remember, data is only useful if it meets certain quality standards. First and foremost important is accuracy. Good data must be free from errors and mistakes. If the sales figure for a product is recorded as 1000 when in reality it was 100, that wrong entry can mislead management into making the wrong decisions. Data must also be complete. Missing values reduce its usefulness. For example, if you have customer records with names but no contact details, you how will you reach them for marketing or service? So, complete data means having all the necessary fields filled in. Good data must be consistent across different systems. Like if one system records a customer's data of birth as a day, month, and then year, and another records it as a month, day, and then year, that inconsistency could cause serious confusion. Consistency ensures that the same data means the same thing everywhere. Data must be available at the right time. Outdated data is almost useless. For example, stock market data from last year cannot guide you in today's trading decisions. So, timeliness means data is up to date and delivered when needed. Data must also be relevant to the purpose for which it is collected. For example, if you are studying customer preferences for coffee flavors, then their shoe size is irrelevant information. Collecting irrelevant data wastes storage and effort. D- Good data must be readable, meaning it comes from trustworthy sources. For example, if you want to know Pakistan's population, a figure quoted from the official census is reliable, but a random number from social media is not. Data must also be accessible to authorized users. If data is locked in some system and nobody can retrieve it when needed, then even the best data has no value. But remember, accessibility does not mean open to everyone. It must be available to the right people at the right time under proper security controls. Good data must conform to the correct format and standards. Like if the system expects a date in the format like day first, then month, then at then year. So validity means data fits the required rules and standards. Finally, data should be cost effective. Collecting, storing, and maintaining data involves cost. So, the benefits of the data must outweigh the cost. For example, running a survey that costs millions of rupees but only provides very little useful information may not be justified. Alright, let's recap the characteristics of good data. It should be accurate, complete, consistent, and timely, relevant, reliable, accessible, valid, and cost effective. Now, here is a quick exercise for you. Imagine you are running an online store. One customer orders a product but enters the wrong phone number and uses an old email account. Which qualities of good data are missing here? Think about it because this is exactly how real world problems arise when data quality is ignored. So far, we have covered the types of data, sources of data, and what makes good quality data. But having data alone is not enough, just like raw cotton is useless unless processed into cloth. So raw data must also be processed into meaningful information. That's where data processing comes in. Data processing is the conversion of raw data into meaningful information through a series of steps. Think of it as a pipeline. Step 1 involves collection, and collection is gathering raw facts like sales invoices. And step 2 is input. Input is entering them into a system, maybe through data entry or automated scanning. And step 3 involves processing, which is sorting, calculating, summarizing, and analyzing. And step 4 is storage, which is saving data for future use, often in databases. Step 5 is output, and output producing reports, dashboards, or summaries. And the step 6 is feedback, which is using results to improve the next cycle of data collection. So, the ultimate goal is to transform data into information that supports decision making. Let's take a simple example. Imagine a supermarket. Every time you buy something, the cashier scans the product barcodes. That scan creates a raw data entry like product code, price, date, time, and the system then processes this by linking it with inventory levels, updating the stock count, and recording the sales amount. Later, the manager can run a report showing which product sold the most this week. That report is information generated from raw data. Now, let's talk about how information flows into an organization. Top down flow. Uh, Senior management sends instructions, strategies, or targets downward. For example, the board sets sales targets which flow down to regional managers and then to sales staff. Bottom up flow. It is the information from operations and staff flows upward to management. For example, sales numbers and customer complaints are reported upward for review. Horizontal flow is the information moves between departments. For example, sales data flows to production to ensure enough goods are manufactured, and to finance to ensure billing and cash collection. So, effective organizations have smooth, accurate, and timely information flow in all directions. This is one of the most exam relevant and practical parts, the role of data in decision making. Management decisions can be strategic, tactical, or operational, and in each case, data is the foundation. Strategic decisions. These are long term, like whether to expand into a new country. Management needs external market data, competitor analysis, and financial projections. Tactical decisions. These are medium term, like setting quarterly sales targets. Managers use past sales data, marketing campaign performance, and customer trends. Operational decisions. These are day to day, like reordering stock or scheduling staff. These rely on real time data like current inventory levels or daily sales. So you can see from the boardroom down to the shop floor, data drives every decisions. In today's world, organizations are moving towards data driven decision making. This means relying on data and analysis rather than gut feeling. Benefits include more objective decisions, better ability to forecast and plan, quick identification of trends and problems, and higher efficiency. Like Netflix uses data analytics to decide what shows to produce. They don't guess. They analyze viewing patterns of millions of users and then invest in shows that match the demand. That's data driven decision making in action. Okay, let's recap this. Data must be processed into information through steps like collection, input, processing, storage, and output. Information flows top down, bottom up, and horizontally across departments. Data supports decisions at all levels, like strategic, tactical, and operational. And modern businesses rely on data driven decisions making for accuracy and efficiency. Here is the quick thought for you. Can you think of one decision in your daily life that you make based on data. For example, choosing a route to avoid traffic using Google Maps. So far, we have seen how data is processed and used for decision making, but here's the reality. Once data is created, it does not just sit there forever. Every piece of data goes through a life cycle from the moment it is created until the moment it is no longer needed and eventually disposed of. Understanding this life cycle is crucial for accountants, auditors, and IT professionals because at each stage there are risks and responsibilities. Stages of data life cycle. Number one is data creation. This is very beginning. Data is created whenever a new transaction, record, or activity takes place. For example, a customer places an order online. That order creates a sales record. And similarly, a new employee is hired, their HR record is created. Data creation must be accurate from the start, otherwise, the errors will continue through the entire life cycle. And number two is data storage. Once created, data must be stored securely. This could be in physical files like databases, servers, or cloud storage. Storage is not just about saving the data, it's also about protecting it against loss or unauthorized access. And number three is data usage. This is where data is accessed and used for day to day operations, reporting, and decision making. For example, customer purchase data is used by the marketing team to analyze buying patterns and launch promotions. And number four is data sharing or transfer. Sometimes data needs to move between departments or even between organizations. For example, payroll data may be shared with banks for salary transfers, or sales data may be shared with suppliers for inventory planning. At this stage, data confidentiality and integrity are especially important. And number five, data retention. Organizations don't delete data immediately, they keep it for a certain period, often due to legal, regulatory, or business needs. For example, tax records may need to be kept for 6 or 7 years as per regulations, but keeping data longer than necessary increases storage costs and risk. And number six is data disposal or destruction. Finally, when data is no longer needed, it should be disposed of properly. For physical files, this might mean shredding. For digital data, it could mean secure deletion or wiping from servers. Improper disposal can cause serious issues. For example, if customer details are thrown away in the trash without shredding, anyone could misuse them. So remember, the data lifecycle stages are creation, storage, usage, sharing, retention, and disposal. At each stage, there are risks that must be managed. Now, let's turn to something equally important, the ethics of data handling. With so much personal and organizational data floating around, there are serious responsibilities. Misuse of data can damage reputation, break laws, and harm individuals. So, confidentiality. Data should only be accessible to people who are authorized to use it. For example, an employee's salary record should not be visible to everyone in the company. And integrity. Data must be protected from unauthorized changes. Altering customer balances or tampering with medical records would be highly unethical and illegal. Transparency and consent. When collecting personal data, organizations should inform individuals about how their data will be used and ideally get their consent. For example, when you sign up for a website and it takes you to agree to terms and conditions, that's part of obtaining consent. Minimization. Only collect the data that is necessary. If you are selling books online, you don't need to ask customers for their blood group. Collecting unnecessary data is unethical and increases risk. Accountability. Organizations must be accountable for the data they hold. If a data breach occurs, they should take responsibility, inform affected individuals, and fix the weaknesses. Compliance with laws. Different countries have laws like or personal data protection laws in other regions. Organizations must comply with these legal requirements to ensure ethical and lawful handling of data. Let me give you a real world example. In 2018, Facebook was criticized because data from millions of users was improperly shared with a company called Cambridge Analytica. This data was then used to influence political campaigns. That incident highlighted how important ethical data handling is, not just for compliance, but also for maintaining public trust. All right, let's recap this quickly. Data goes through a life cycle from creation to storage to usage, then sharing, retention, and at the end disposal. At each stage, proper management is critical. Ethical data handling means maintaining confidentiality, integrity, transparency, minimization, accountability, and legal compliance. Here's something to think about. Imagine you are running a tuition center and you have student records. What ethical responsibilities do you have towards that data? Should you share it with anyone outside the tuition center? So far, we have looked at how data flows through its life cycle and ethical responsibilities tied to it. But let me ask you a big question. Is data just a byproduct of business operations, or can data itself be a source of power? The answer is data is no longer just an operational tool. In today's digital world, data is a strategic asset. It can give organizations a huge competitive advantage. When we call data a strategic asset, we mean that it is just as important as money, people, or equipment. Think about it. Organizations invest millions in collecting, storing, and analyzing data. Why? Because it helps them make better decisions, predict the future, and outperform competitors. Data can create competitive advantage in several ways, like better customer understanding. By analyzing customer data, businesses can understand preferences, buying behavior, and needs. For example, Amazon uses customer purchase history to recommend products. This keeps customers engaged and increases sales. Personalized products and services. Companies use data to offer personalized experiences. For example, Spotify and YouTube recommend music or videos based on your listening or watching history. This keeps users hooked and reduces churn. Improved efficiency. Operational data helps businesses reduce cost and improve efficiency. Like airlines use data to optimize ticket pricing and flight scheduling. Ride hailing apps like Uber use data to match drivers with passengers in real time. Innovation. Data driven insights can spark innovation. Like pharmaceutical companies analyze massive amounts of medical data to discover new drugs and predict which treatments will work best. Risk management. Data also helps in identifying and managing risks. For example, banks use credit history data to decide whether to approve loans. Insurance companies use data to calculate premiums and detect fraudulent claims. Let's look at some well known companies that have used data strategically. Google, as their entire business model is based on collecting search data, analyzing it, and using it for targeted advertisement. That's why they are one of the richest companies in the world. Netflix uses viewing data to not only recommend shows but also decide which new series to produce. House of Cards and Stranger Things were greenlit because data showed huge demand for those genres. Coca-Cola uses data analytics to track customer trends worldwide and adjust marketing strategies for each region. So, whether it is tech, entertainment, or even soft drinks, data is central to strategy. Of course, it's not all smooth sailing. Organizations face challenges when trying to use data strategically. Data overload, like too much data, can overwhelm decision makers if not managed properly. Data quality issues, like if the data is inaccurate or incomplete, the analysis will be misleading. Security and privacy concerns. Customers won't trust a company that misuses or leaks their data. Skills gap is not every organization has experts who can analyze and interpret data correctly. So yes, data is powerful, but it must be managed carefully to truly provide competitive advantage.